In today's note, we're going to look at our third and final method for solving a linear system, which is solving by elimination. So it's similar to solving by substitution, as we are going to be doing something to the equations where we remove one of the variables, and so that we're only left with one, which we can then solve, and then plug back in to solve for the final value. So the steps for this one, first step is to decide which variable we want to eliminate. Right? So we want to determine, are we going to get rid of like the x variable or the y variable. To eliminate a variable, it must have the same numerical coefficient in both equations. So basically the number in front of the variable needs to be the same in order for us to eliminate it. And one thing to note, it's just the number, it's not the sign. Because in the next part, to eliminate, we either add or subtract the equations based on the signs of the variable. Right? So it doesn't matter what the signs are, it's just as long as the number is the same. Or the numerical coefficient, technically, as long as that is the same. So if the signs are the same, then we subtract them. So two negatives, we subtract them. Two positives, we subtract them. And if the signs are different, we add them. So a negative and a positive, in whichever order, we add them. And then once we do that, we're left with only one variable, which we can then solve. So I'm going to look at the first example. I want to solve each of these systems. So if I look at A, I have one equation and I have two equations. So the first equations, or what my first step is, I need to determine which one am I going to eliminate, which variable am I going to eliminate. I'm going to focus on getting rid of the y's. And the reason that I'm doing that is because remember that I need to get the coefficient, so the number in front of the variables, the same. And if I look at these two, even though these are not the same, there's something that I can do to easily change that. And what I'm going to do is I'm going to keep equation 1 the same. So equation 1 is going to be the same. So 7x minus 4y equals 3. And now for equation 2, I'm going to multiply that entire equation by 2. And the reason that I'm doing that is because if I change the entire equation by 2, I'm not really changing it. I'm just changing the numbers. I'm doubling it, but the equation is still the same. And when I do that, what I'm left with, so if I take 6 times 2, it's 12x, plus 2 times 2, which is 4, so 4y, and 8 times 2, which is 16. So I've multiplied this entire equation by 2, and now I see that my coefficients in front of the y's are the same. If I tried to do that with the x's, I would have to multiply both equations, which is adding more work. So I'm going to focus on the y's, and because the variables are, the signs are different, I need to add them. And so what that means is we're going to add our equations. So I'm going to carry down the equal sign. 3 plus 16 is 19. So basically you're just adding in columns, right? If you have to put columns down and you're adding them up. So negative 4y plus 4y, again, this cancels out, right? Or they eliminate each other. So basically that just becomes 0. And then 7x plus 12x is 19x. So that's the goal of elimination. We can put plus here if we want. We want to get rid of one of these variables. And by adding the two, we've gotten rid of the one variable of y. So now all we're left with is 19x equals 19, because I don't need to include that 0. And now I can solve. Right? I can solve for x, so I'm going to divide both sides by 19. One side cancels out, and I'm left with x equals 1. So this is part of my solution. Now that I've solved that, I can go back and I can sub x equals 1 into, again, I can choose either equation. I'm going to pick equation 2. So now what we have is we have 6x plus 2y equals 8. And everywhere we see the x, we're going to replace it with 1 plus 2y equals 8. So 6 plus 2y equals 8. I'm going to move the 6 over. So 2y equals 8 minus 6, which is 2. Divide both sides by 2. You're left with y equals 1. So, after all that, we get, therefore, the solution, or you could say the point of intersection, the solution is 1, 1. In our next example, we're going to do the same thing. So we want to, I'm going to just label it 1 and 2. We want to determine which variable we want to get rid of. Again, we can choose to do either one. In this case, because neither one is nice, and what I mean by that is it's not easy to change just one to the other, I'm going to just say pick y. Again, you can choose x. The steps are going to be slightly different, but they're going to be roughly the same. So the first thing I need to do, I need to get my variable, or the coefficient in front of my variable y, to be the same number. Right now it's 4 and 3. And the way we get it to the same number is I'm going to take equation 1 and multiply it by the coefficient of the other one. So in this case, the coefficient of the other one is 3. And if I take equation 2 and multiply it by that, it's the other coefficient, which would be 4, right? Because the 4 is in 1 and 3 is in 2, so I'm just multiplying it by the other. So that means if I'm going to multiply all of equation 1 by 3. So I'm going to get 24x minus 12y equals 48. Then my second equation, I'm going to multiply everything by 4. So 20x minus 12y equals 44. And now what we're doing is now we can decide, am I going to add or subtract these two equations to cancel out the y's? Because the signs are the same, I'm going to have to subtract. But keep in mind, you're subtracting the whole equation, not just part of it. So I'm going to do everything in my columns again. Again, just to help me organize it. So 48 minus 44 gives me 4. Negative 12 minus negative 12 cancels out to give me 0. And 24 minus 20, or 24x minus 20x, gives me 4x. So I can rewrite this to just 4x equals 4. And now I can go through and solve. I can divide both sides by 4. One side cancels out. And I'm left with x equals 1. So I have part of my equation already. The next step is I'm going to take that answer and sub x equals 1 into either equation. It doesn't matter which one you pick. I'm going to plug it into equation 1. So 8x minus 4y equals 16. X is now replaced with 1, so 8 times 1 minus 4y equals 16. So 8 minus 4y equals 16. If I'm going to move the 8 over, so negative 4y equals 8. Divide both sides by negative 4. Y equals negative 2. So, therefore, the point of intersection, or the solution to the system, is 1, -2, because the x value is 1, the y value is -2. In example 2, I still want to solve this system of equations algebraically. I want to do it by canceling them out. However, I have fractions. So what I want to do is, in my equation 1 and in equation 2, I want to eliminate the fractions. And the way I'm going to eliminate fractions is by multiplying each equation separately by a common denominator. So if I look at the first one, the 1 over 3x minus 9y equals 5. There's only one fraction here, so there's only one denominator that I have to worry about. In this case, it's 3. So I'm going to multiply this equation by 3. And what I'm going to get, if I do 1/3 times 3, that cancels out, so I get x minus 27, y equals 15. In my second equation, I have two fractions, 4 and 2. So the common denominator of these two is 4, because 4 goes into 4 and 2 also goes into 4. So I'm going to multiply this entire second equation by 4, and to do that, and the result of that, is I have x, because 1/4 times 4 is x, minus 12y equals 2. So now I have my two equations. I've gotten rid of the fractions, so now I can solve by elimination. And I can see that I already have a variable with the same coefficient in front. So I have my x minus 2y equals 15, and I have x minus 27 equals 15, x minus 12y equals 2. And if I look at the x value, because the symbols in front are the same, I am going to subtract these equations. Keep in mind to put brackets around the entire second equation, because you're subtracting everything. I'm going to put my columns down just to make it a little bit easier. So x minus x is just 0. 27y minus -12 is -15. Y equals, and then 15 minus 2 is going to be 13. So I have -15y equals 13. To get y by itself, I'm going to divide by -15. One side cancels out, and I'm left with y equals -13 over 15. So that is my y value. To get my x value, I need to plug this into an equation, and I'm just going to pick anyone. I'm going to pick the first one in this case. So I'm going to sub into 1 because there's only one fraction there. Actually, well, I'm going to use the one that I've already changed. So I'm not going to try it. I'm trying to deal with as few little fractions as possible. So I'm going to sub it into equation 1, which is x. Or sorry, not equation 1. Let's pick equation 2, because the numbers are smaller. So I have x minus 12y equals 2. I'm going to replace the y with -13 over 15. Let me just fix my brackets. When I'm multiplying my fractions, remember I multiply straight across. So this 12 is actually over 1. So x minus, or sorry, plus now because it's two negatives, 156 over 15 equals 2. this can simplify, so x plus 52 over 5 equals 2. I'm going to move it over. X equals 2 minus 52 over 5. And when I simplify this, let me just bring this up over here, or actually make it a little bit easier. When I simplify this, x equals negative 42 over 5. My final answer. So even though I'm dealing with fractions, it's still going to be my solution, and we can see this is an example where graphing it would be very difficult. So therefore, the solution is negative 42 over 5 and negative 13 over 15. So those are that is my solution to this linear system. So even though we have fractions, it's still solvable. It may just take a little bit more work. Example 3, so now we're dealing with a word problem. Every day at her bakery, Brittany bakes chocolate chip cookies and oatmeal cookies. She uses different amounts of butter and oatmeal in each recipe. Each batch of chocolate chip cookies uses 13 kilograms of butter and 8 kilograms of oatmeal, while each batch of oatmeal cookies uses 2 kilograms of butter and 29 kilograms of oatmeal. If she has 47 kilograms of butter and 140 kilograms of oatmeal, how many batches of each type of cookie does she bake? So we need to come up with our two equations, but before that, we need to come up with what our variables are. So let's let C represent the number of batches of chocolate chip and let M represent the number of batches of oatmeal. So basically just trying to use a letter that doesn't look like an operation. So I need to come up with my two equations. And my two equations are going to be one based on butter and one based on oatmeal, because those are the two common things. So the butter equation is going to be 13, because 13 kilograms times C for the number of chocolate chip batches, plus 2 M for 2 kilograms for the number of oatmeal batches, equals, and then in total 47. For oatmeal, it's going to be 8 times C for chocolate chip plus 29 M for oatmeal and equals 140. So here we have our two equations, equation 1 and equation 2. If I look at these variables, neither of them has the same coefficient in front. So because they don't have the same coefficient in front, I need to pick one variable to focus on and then change both equations so that they fit, or so that the coefficients are the same. I'm going to focus on the C. Again, you can choose whichever one. The steps are going to be slightly different. But for equation 1 and equation 2, I need to change them. And in this case, I need to find a common number, and the easiest way to do that is to multiply the entire first equation, so the blue one or butter, by the coefficient of the bottom one. So because we're focusing on C, the coefficient on the bottom equation is 8. So I'm going to multiply the first equation entirely by 8. And then equation 2, I'm just going to do the reverse. I'm going to multiply everything by 13. So in the end, I should have 104c, so 13 times 8, plus 2 times 8, which is 16m, equals 376, so 47 times 8. Second equation, again, the first number will be the same, 104c, plus 29 times 13, 377m, equals, and then 140 times 13, so 1,820. Now that we have our two equations, we have the same coefficient in front, now we can eliminate. And in this case, we are going to eliminate by subtracting, because the variable, or the coefficient in front, or the signs, are the same. Right? They're both positive, so I'm going to subtract these two equations to get my answer. In this case now, the first one will cancel out. Actually, let me throw in my columns to kind of separate everything. So the first one will just be 0. Then I have 16 minus 377. So I get negative 361m equals 376 minus 1,820. So negative 1,444. So that means I've eliminated one variable. I'm left with negative 361m equals negative 1,444. I'm going to get m by itself by dividing both sides by 361, or negative 361. Cancel out, and I'm left with m is equal to 4. So I know part of my solution. I know the number of batches of oatmeal cookies is going to be 4. However, I'm not done. I need to sub into, and I'm just going to pick one. I'm going to sub it into equation 1. Again, you can choose to sub it into any equation and your answer should be the same. So I'm going to sub it into equation 1. So I have 13c plus 2m equals 47. 13c plus 2 times 4 equals 47. 13c plus 8 equals 47. I move the 8 over. 13c equals 39. Divide both sides by 13. And I get c equals 3. So I have my two solutions. So therefore, she made 4 batches of oatmeal and 3 batches. Let me just move this. 3 batches of chocolate chip. So this is, again, just looking at how we can solve by elimination. Right? Remember the steps. You're basically trying to get the same numerical coefficient in front of one of the variables. Once you do that, you are going to either add or subtract the equations to cancel that variable out. Then you're going to go through and solve for that missing variable and then sub it back in, similar to what we've done with solving by substitution. And again, steps are very similar, except for that first part where you're isolating a variable. If you're using a word, if you're dealing with a word problem, again, remember, figure out what your variables represent, come up with your equations, and then use one of your methods of solving the system to figure out your solution.